In our last module we explored why we use multipass rendering. In this module we're going to look at the how we do it in V-Ray and Maya. Firstly, we're going to set up V-Ray and the basic render settings that we're going to use in this course. And then we're going to look at our test render and examine the V-Ray frame buffer, which is very handy. We're then going to set up our beauty AOVs. And then we're going to troubleshoot some of the issues we saw in the last module. So here we are in our first Maya scene. And just to make sure that V-Ray is operational, we're going to open our render settings and we can see that we're set up using V-Ray. Now it may be that when you open this you find you're set to Maya software or some other renderer. It may even be that V-Ray is not in the menu. If V-Ray is installed and it's not in the menu, you can simply go to Windows, Settings and Preferences, Plugin Manager, and make sure down here that you have V-Ray for Maya loaded, and if you want it to load every time you open Maya you can set it to auto load. In this case we've already done that, so we're ready to go. So we're going to be rendering the image format EXR multi-channel. This is a format which was created by ILM, and the great thing about it is we can keep all of our render passes in a single file. We're going to render using names. We'll talk a bit about names later on, but just for the moment you can see I'm using these tags here. So the name of the scene and the name of the camera underscore the name of the version, and then that's a slash, so that will be a folder. Within that folder the file will be the name of the scene underscore the name of the camera underscore the version, and this actually shows you what the file path will look like. There's a preview up here, and that's going to our Maya Images folder. So I'm not going to render animation for the moment. I'm going to render my RenderCam 2, and I'm going to use 720p, which is a very low res format, but it may be that even when your production format is considerably higher, you may wish to render at a smaller format, especially while you're setting up your project. So if your final resolution is HD, you may be setting it 720. If your final resolution is, even if it's 4K, you might want to start rendering at HD. You can actually set up a test render within the V-Ray frame buffer to render at half res, but it's good to actually keep your settings lower as well, because you want to iterate quickly while you're setting things up. Now down here we're using the V-Ray frame buffer, so instead of the Maya render buffer we're going to use the V-Ray frame buffer, and we're going to use just as we did in Nuke, we're going to actually do the previews in sRGB, so with our magic sunglasses. And that's all for the common settings. Within the V-Ray, we're going to be using the production engine of the CPU. Now, the GPU is faster, but it is in fact a different renderer. It's a perfectly good renderer. You can use it as a production renderer, not just for previews, but I would like you to understand that it will give you a different result, and not all the features will be available within the GPU renderer. I have set up the GPU renderer in the IPR for RPR renders. So this is the CPU is going to use buckets, which means it will render little blocks one at a time. These are mostly default. Now here is where we decide how fast. It's a sort of trade-off between quality and speed. So the minimum subdivision is going to be 1. Our max subdivisions will be 36, so it's an arbitrarily high number. Chaos Group even recommend as high as 100. Which means that this threshold will determine how many samples it will actually create. So this is the threshold in the difference in value between that pixel and the next pixel, which will decide whether it needs to subdivide that pixel more to give you a more accurate result. Now 0.4 is quite good for production, it might even go a little bit lower, but for the moment of setting it up we're happy to have it a bit noisy, but we just want it fast. So I'm going to set it to 0.5, 0.4, which is not going to look great. It's not a production quality render, but it will get us renders out the door quickly, so we can check things out. Now here we have color mapping. Now it can be set to linear multiply or Reinhard. Now Reinhard is linear multiply for the most part, unless you use this burn value, and basically with the burn value you can sort of do a soft clip of your super whites, your values over 1. Now if you're doing compositing in another package like Nuke, you're not going to use that. So if you keep the burn value at 1 and multiply at 1, this is the same as linear. Gamma 2.2 is our approximately sRGB, so this is what we're using to preview our image. And color mapping only, no gamma. So we're actually not applying any of this while we're rendering. We are rendering linear images, and then just like we did in Nuke, we're looking at them with the magic sunglasses. So that's all for that. GI is also going to determine our speed. I'm going to start using brute force for our primary bounces and the light cache for our secondary bounces. So the light bounces once off an object, and that's our primary bounces. If it bounces off, if those bounces then bounce off the table or whatever, those are secondary bounces. The light cache has 500 subdivisions, so it's quite small. It's going to use a single frame, and there we go. Now we have caustics. These we've seen them; they look a bit splotchy. Again, I say if you can't get them looking good, if you can't get the settings high enough to get good looking caustics, it's probably better to switch this off. You can get light coming through transparent objects in a simpler and faster way. Caustics, of course, are more photoreal, and if you can set it up to with higher settings, you can obviously use caustics quite well. But for the moment, I'm going to switch them off again for speed, and I'm going to close that. So I've not actually set up any render elements yet. I'm just going to hit render and see what we get. In our next clip, we'll look at the V-Ray frame buffer.